Hello! This is part 3 of the Atoms and Light series about emission spectra and the Bohr model of the atom. Let's start with a quick review from physics. This is the electromagnetic spectrum. Right? Let's talk about what light is. So we know that there are many colors of visible light. The rainbow from red, orange, yellow, green, blue, indigo, violet, but that's just the light that we can see. There are other types of light that we can't see. Radio waves, microwaves, infrared radiation, visible light, and then there's ultraviolet and X-rays and gamma rays. And you can see at the top of this diagram that these different types of electromagnetic waves have different wavelengths and they have different frequencies. And each color or each type of wave, whether it's red light or green light or X-rays or microwaves, has a different wavelength and a different frequency. That's the difference between them. But they also have another difference, and that is a difference in energy. That's what we're going to focus on here. So different colors of light have different amounts of energy. Red light and blue light and yellow light have different amounts of energy. Infrared light and X-rays have different amounts of energy. That's what we need to know here. Next thing we need to know, if you looked at the simulation, you probably noticed that electrons move differently. Here's what I mean. Imagine you're at the bottom of the stairs and you want to go upstairs. How do you get upstairs? Well, you going upstairs probably looks something like this. Right? You're at the bottom of the stairs and you go one step at a time up to the top of the stairs. Even if you skip over one step, maybe you take 2 steps at a time, you still have to move through, all the way up the staircase. Electrons move differently. Here's on the right side of the screen, here's an electron at level 1, and then to get to level 2, it just jumps. You can't do that. Electrons teleport. Level 2, level 1, level 2, level 1. And the cool thing about electrons is that they can jump between levels without ever having been in between levels. They are never in between levels. They just jump from one level to another. So electrons move differently than probably anything you've ever seen. All right, this is one of the cool things in quantum mechanics, that when things get really, really tiny on the scale of atoms or electrons, the rules are just different. Lots more of that as you continue to study physics and chemistry. So let's look at how atoms emit light. This is a 3-step process. Step 1, this is what we saw in the simulation. Step 1, an electron absorbs energy, usually from a photon. A photon is a light particle. And when it absorbs that energy, it jumps up to a higher energy level. Right? So it's on level 1, that's called the ground state. And when it absorbs energy from a photon, it jumps up to a higher energy, level 3, level 4, or whatever it is. And then, now that the electron has all that energy, at some point it will fall down to a lower energy level, right? My hand has to move through space, but the electron just jumps. And when it releases energy, it releases that energy in the form of a photon. So the electron absorbs energy and jumps up, and then releases energy and falls down. And part 3, the specific color of the photon that the electron emits is determined by the difference in energy levels. The amount of energy that is gained or lost by the electron will determine the color of the photon, because different colors of light have different amounts of energy. So the electron can release a red amount of energy or a green amount of energy, depending on the difference in energy levels. That's how atoms emit light. But we don't need energy levels to explain how atoms emit light. Electrons, imagine if they could be any distance from the nucleus. There's the nucleus down in the middle. And the electrons could fall any distance to the nucleus and emit any color. If they're close and they fall a short distance, that would be red. Or if they are farther away and fall larger distances, that could be any color of the rainbow. But that's not what happens. We saw in the first video that electrons only emit certain colors. And Niels Bohr's idea was that the reason electrons can only emit certain colors is that they can't be anywhere. They can only be on certain energy levels, and they can only jump between levels. So here's a diagram, not to scale, of the energy levels of a hydrogen atom. And it's these specific jumps, not any jump, but only specific jumps, that cause these specific colors. For example, when the electron is at level 3 and jumps to level 2, that is a red amount of energy. A bigger jump, like level 4 to level 2, there's blue-green. Or level 5 to level 2, that's a darker blue amount of energy. Level 6 to level 2, that's purple. And the other jumps also emit different colors of light. They're just invisible light. So any jump to level 1 releases ultraviolet light. Any jump to level 3, or drop to level 3, releases infrared light. So this is the reason why atoms and the electrons in atoms can only emit specific colors, because they can only be on an energy level. What if this atom were to emit yellow light? Could this atom emit yellow light? Well, yellow is between red and blue on the rainbow, so it has an amount of energy in between the red amount and the blue amount. But if you look at the yellow arrow, you will see that that is impossible. Right? This atom can never emit yellow light. And the reason this is not possible is that in order to do that, the electron would have to jump from a place where it cannot be. It would have to jump from level 3.5 to level 2. And that is impossible. Electrons can only exist at specific energy levels. So here's our summary again of how atoms emit light with our key step 4. Because electrons can only exist at certain energy levels, never in between, they can only emit certain colors. And that is how the Bohr model of the atom, which defines electrons existing at energy levels, explains emission spectra of atoms. Thank you for watching.